Hello everyone, today I am going to solve question number 2 of SSB Odisha lecture exam 2023. Here question number 2 is come from group theory part. Question say if H and K are two subgroup of group G, then which one of the following is not true? Okay, so let's come to option A. Option A says if H is a subset of K or K is a subset of H, then HK is a subgroup of G. So before that it is given already. H is a subgroup of J and K is a subgroup of J, and HK is defined by small h into small k, where H belongs to H and small k belongs to capital K. Okay, so we have to prove HK is a subgroup of J, this one. So before that we have to know how to prove a subset of group G is subgroup of J if it satisfies this condition, that is AP inverse belongs to H for all AB belongs to S. If this condition satisfied, then we can say H is a subgroup of G. So to prove this one, so take any one condition because it is mentioned here. Either H is a subset of K or K is a subset of H. So I take here, suppose H is a subset of K. So to prove HK is a subgroup of G, so take any two element, that is H1 K1 and H2 K2 belongs to HK. Okay, so just operate H1 K1 H2 K2 inverse, that is H1 K1 into K2 inverse H2 inverse. So as you can see, since K is a subgroup of J and K1 K2 belongs to K, so K1 into K2 inverse also belongs to K, and H2 belongs to H, so H2 inverse also belongs to H, because H is a subgroup of J and it satisfies subgroup satisfy inverse property also, and H is the subset of K because I already taken here. So this H2 inverse also belongs to K. Okay, so this belongs to K and this one is also belongs to K, so overall the product belongs to K because this is also yes subgroup. K is a subgroup, so the product it also satisfy closure property. So and H1 belongs to H, so overall element belongs to HK. So here by this result we can say HK is a subgroup of J. So option A is true. Okay, so let's come to option B. Here option B say if HK is equal to KH, if HK equal to KH, then HK is a subgroup of J. Similar way by prove this one also. So take two element, that is H1 K1 H2 K2 belongs to HK, and just operate this two element by H1 K1 into H2 K2 inverse, that is H1 K1 into K2 inverse H2 inverse. So here since HK equal to KH, that means what, their element also commute. So here H1 K1, that is K H1 K1, just write this one, and K2 inverse H2 inverse I can all write it as by this way, H2 inverse K2 inverse, because these are commute. So also write H1 H2 inverse also came to this place, so H1 H2 inverse into K1 K1 K2 inverse. Okay, so there is no confusion here, I think. So this as H is a subgroup of J, so this one belongs to H. Since also K is a subgroup of J, K1 K2 inverse belongs to K. Okay, so overall element belongs to HK. So therefore here we get HK is a subgroup of J. So option B is also true. Okay, so now let us come to option D. Okay, this one we have to check. If G is a commutative group, then HK is a normal subgroup of J. G is a commutative. Commutative means abelian group. Here it is mentioned option D. G is commutative. G is commutative group. That means what? G is abelian. Okay, so abelian means every element are commit, so that is hk equal to kh. Okay, so I think there is no confuse. So since hk is equal to kh, and we proved earlier in option b, if hk equal to kh, then hk is a subgroup of j, and as we know, every subgroup of a abelian group is also a normal subgroup. Okay, since hk is a subgroup of abelian group j, so hk is normal, normal in j. Remember these things: every subgroup of abelian group, every subgroup of abelian group, abelian group is normal. Okay, so this one remember always. Therefore option d is true as well. Okay, so option D is true. So only option C is left. Option C. So if question is true, then option C must be wrong. So option C is say if H or K normal subgroup of G, then HK is normal subgroup of G. This is not necessarily true always, because as we know. So remember this thing and note. So if H is a normal subgroup of G or K normal subgroup of J, this doesn't imply HK is normal subgroup of J. But if one of them is normal, then HK is subgroup. But you can't say HK is normal subgroup of J. So if both of them, if H is normal in J and K is normal in J, this also doesn't imply HK is normal in J. Okay, so option C is true. Okay, is sorry, option C is false. So option C is true here. Okay, so thank you.